You know, when you hear words like alternate dimensions or multiverse, your mind probably jumps straight to comic books, right? To science fiction. But what if I told you that some of the sharpest minds in physics are taking these ideas very, very seriously? Today, we're going to peel back the fiction and look at the actual science that suggests our universe might be just one of many.
And that's really the big question, isn't it? Is this it? Is everything we see, all the stars and galaxies, is that the whole story? It's a question that pushes right up against our most basic ideas about reality, and honestly, the possible answers get pretty wild. So our first stop on this little tour is going to take us to the biggest scale imaginable, the entire cosmos. The core idea here is that our universe isn't the whole show, but maybe just one small piece of a much bigger, more incredible structure. A really helpful way to picture this is to think of a giant patchwork quilt, right? Imagine this huge quilt where every single patch is its own universe. From far away, it's all one thing, but when you get close, you see each patch is totally unique. It's a fantastic way to think about how all these different universes could exist together. Okay, so where does this idea even come from? Well, it ties into cosmic inflation, that moment just a fraction of a second after the Big Bang when the universe expanded incredibly fast. The theory goes that while our little pocket of space stopped inflating and cooled down to become, our universe, other parts of space just kept going. They're still inflating forever. And in this eternally expanding cosmic foam, new bubble universes like ours are popping into existence all the time.
So, what would these other universes actually be like? Well, physicist Max Tegmark suggests different levels. A level 1 multiverse is basically just the result of space being infinite. If space goes on forever, then sooner or later, every possible way particles can be arranged has to repeat, which means way, way out there, there's another you, literally. But a level 2 multiverse, that's even stranger. In this version, different bubble universes could have completely different laws of physics. Maybe gravity is way stronger, or the charge of an electron is different. They would be worlds that are fundamentally alien to us.
All right, we've just been talking about the infinitely large. Now let's flip the script and dive into the infinitely small, the quantum world. And trust me, this is where things get really, really weird. Get this. This idea isn't about universes that are billions of light years away. It's about universes being born right here, right now, with every tiny quantum interaction. It's a pretty radical idea that actually tries to solve one of the deepest puzzles in all of physics. So, in the quantum world, a particle can be in many states at once. It's called superposition. But the second we look at it, we only ever see one result. The many worlds interpretation says, well, what if the universe doesn't pick one outcome? What if instead the entire universe splits? In one universe, you measure outcome A. In another, a perfect copy of you in a parallel universe measures outcome B. Every single possibility plays out, each one becoming real in its own separate world. And you know, this isn't some brand new sci-fi concept. It was first thought up way back in 1957 by a physicist named Hugh Everett for his PhD thesis. It was later popularized by Bryce DeWitt, who gave it the much catchier Many Worlds name. This quote from DeWitt just perfectly captures the mind-boggling scale of this idea. We're not just talking about big decisions. We're talking about every single quantum event everywhere in the cosmos, constantly branching reality into this insane, ever-growing tree of parallel universes. Okay, so we've had universes that are super far away, and we've had universes splitting off from our own every second. Now for our third major theory. This one comes from string theory, which is one of the biggest attempts at a theory of everything. And it suggests our entire universe is just floating around in a higher dimension. In this model, our universe, all three dimensions of space plus time, is what's called a brane, which is short for membrane. And this brane is floating inside a much larger, higher dimensional space called the bulk. It's kind of like we're living on a single sheet of paper in a massive library full of other sheets of paper. So you're probably asking, why can't we see these other dimensions or other branes? Well, string theory says that most fundamental particles are like open strings with their ends literally stuck to our brane. They can't leave. But gravity is different. It's a closed string, a little loop. So it's not stuck. It can leak out into the bulk. And that might actually explain why gravity seems so much weaker than all the other forces. Now, this whole brane idea depends on some really core parts of string theory. For one, the math needs more than just 3 spatial dimensions to work. Usually it's like 9 or 10. So where are they?
Well, the idea is they're compactified, curled up so incredibly tiny that we can't see them. And get this, some theories suggest that a collision between two of these brains out there in the bulk could be what triggered our Big Bang, a totally different origin story for our universe.
All right, let's take a quick second to recap. We started with the cosmological multiverse, which comes from just the sheer size of space and cosmic inflation. Then we dove into the quantum multiverse, born from the bizarre rules of quantum mechanics. And finally, the brain multiverse, which is an idea that comes out of string theory. So 3 completely different starting points, but they all lead to the same jaw-dropping conclusion: we might not be alone.
And for our final idea, well, just when you thought it couldn't get any weirder, it does. This one doesn't just question if there are other universes, it questions the very nature of our universe, suggesting it's not at all what it seems.
The holographic principle is one of the most mind-blowing ideas to come out of physics, period. But think about it like this. You know the little hologram on your credit card? It's a flat 2D surface, but it looks 3D. The holographic principle suggests the entire universe might work the same way. All the information for a 3D volume of space could actually be encoded on a 2D surface at its edge.
And the scale of this is just staggering. We're not talking about a little volume of space. This suggests that our entire universe, everything you see, everything you are, is just a projection of information that's stored on some distant 2-dimensional surface at the very edge of the cosmos. So what does that mean for the room you're in right now? It means the 3 dimensions you experience every day, length, width, height, they might not be fundamental. They could just be an illusion, something that emerges on large scales, just like the 3D image that pops out of a 2D hologram. So the ultimate takeaway here is that our universe could literally be a hologram. The 3D reality we think is so solid is maybe just a projection of information that's, written down on the boundary of space-time.
And that brings us right back to a fundamental question. From cosmic bubbles and quantum splits to reality being a giant holographic projection, modern physics is forcing us to accept that reality is so much bigger and so much stranger than we ever thought possible. Are any of these ideas right? We have no idea, yet. But the search for the answer is what science is all about.